Hey folks, today I have the pleasure to host for the third time Fabian Contaminas, specialist solution architect who works at Databricks. Hi Fabian.
Hi, Youssef. Thanks for having me today with you. Always a pleasure to be there.
And I think I no longer need to present him, and he will record a series of video with me. Today we are going to talk about two data warehousing concepts.
So it's multi-statement transaction and multi-table transaction. So both features are almost the same. With multi-statement transaction, what we want to do is running in one command multiple operation on any table and fail the whole block in case there is one hiccups. And I will show you that right after with some code. Multi-table transaction is for more complex logic behavior. So it's more familiar with what you could have been running within SQL Server with a begin transaction statement, which is a statement by itself. Then you can run any command you want, and you can at the end decide to either commit or either roll back the whole transaction. So actually, let me show you all this demo.
And I think that's the reason, since we need to manage how things are written, that's why it needs to go through the catalog-based commit from the beginning.
Absolutely. Absolutely. This is very important. So as you see on my screen, we have I will be creating two tables for you, and we have this new properties which is named Delta Feature Catalog Manage Supported that gives an information additional information of the table that the commit is actually managed by Unity Catalog. And this is very important because if you can have multiple committers in your table, then we wouldn't be able to guarantee the veracity of the data with multi-statement transaction. So here, I've just created two tables: MST table one, MST table two. Let me fill two values in both this table. So it's easy. I've for both the tables, I've got an ID, which is identity. So it will be one because I have only one value for both my table, just a timestamp and a value. Okay, so we have our two rows in this table. Let me just display what we have inserted. It's exactly what we have here. So for table one, we have the value one, table two, we have the value two, and both have ID one. So let's say, as you may have not noticed, I've put not null constraints on all my columns in my tables. And what I want to do here, I want to update both my table. For the table one, I want to set the value to the val column to 1.1. And for table two, I want to set the val to null, which is not permitted. So let me run this block of command. And I've got a not null constraint violated for the column, which was expected. But if I go back and look in both my tables, we'll see that actually, so table 2 didn't get updated, but table 1 did. So this statement succeed and this statement fail. And in a lot of scenarios, especially in data warehousing, you want to have, for data validation, for data quality, you want to have like tied logic. So you want to do first some operation on a table, another set of operation on the same table or another table, and so on and so on. But you want all those operations to be consistent. So this is where the multi-statement transaction is actionable. So we have this new keyword that you tie just to the begin here. So when you do a begin atomic, and I will run again the same command, I've just put 1.2 here for the table one. So I'm still expecting the error. So here it is. But when I look into the data, this time we had no change, not for table one, not for table two. Both statements are either committed or rollbacked. So this is very good. But let's say you need to have more complex logic. I don't know. You want to add some data in your table, and you need to check that the sum of something is below a certain threshold. So it's like a complex logic validation. So for this one, this is where we have the multi-table transaction features. So you in this one, it's separated command. Maybe I didn't emphasize enough, but here it's only one command. It's one block of command. This is leveraging SQL scripting. Here, this is natural command. So begin transaction is a new command in DB SQL. So I'm declaring, I'm opening a new transaction. I can, for example, update my table one. So here I've put the number 1.3. I will update my table two with the number 2.3. This time I want this command to succeed. So I can check the value in both my tables. Okay, so 1, 3, 2, 3, I'm happy, this is what I wanted. But let's say I'm implementing more logic and I'm not happy with the result. I can just roll back the transaction. And now if I check again my data in those two tables, I'm back to where I was before running these two update operation. And yeah, this is it. This is a feature. Very easy to use, very natural. And if you are coming from data warehousing or more classical database background, it will feel super easy for you to adjust. And that's it for me, Youssef.
I think that's pretty much so. As Fabian mentioned, we have two new concepts. I mean, not new, but new to Databricks. Multi-statement transactions, where you can make sure that either you fully commit everything or nothing. And then if you have a more complex logic for validations, then you need to go through multi-table transactions.
Perfect.
And both of them rely on the catalog-based commit, which is the feature that Fabien enabled at the table level. Perfect. Thank you so much, Fabian, and see you soon.
Thanks, Youssef. Talk to you soon.
In Lakehouse, rise data seas, lake flow streams the flow. Iceberg and Delta Lake, tables aglow. Unity catalog governs lake base. OLT pitch strong. Ginny text to SQL mosaic and KI prolongs. Yusuf and Quentin co-hosts light the fire.